All right, the next problem is for IF5. IF5 Lewis structure and these molecular properties. So the first thing to do is to calculate the number of valence electrons. I get 7 from the iodine, and I get 35 total, 7 times 5 from the fluorine. Add them together, and the answer is 42. It would be. I hear that is the answer. Now, I would arrange the atoms symmetrically as I could on my paper. So I'm going to kind of look at putting the fluorines around like this. The next step is to draw a single bond to each one of these atoms. I did that. And now I would reduce that valence electron count by the 10 electrons in those 5 bonds. I'm left with 32. Time to start making octets on those fluorines. So I would fill in those electrons here like so. And if with 5 fluorines, 6 electrons each, that means I would have gotten 30 electrons out. So I've got 2 left. Well, what do I do with those 2? I put them next to the iodine because the iodine can do an expanded octet. So I do have an octet on every atom. Iodine is expanded. It's got 6 geometry groups, 12 total electrons. So since it has 6 geometry groups, or sometimes referred to as electron groups, the electron geometry is octahedral. With one lone pair, the molecular geometry of an octahedral structure is square pyramid. So it's square pyramidal. The bond angles are determined from the electron geometry octahedral, so they're 90 degrees. And one lone pair in a square pyramid means the bond dipoles don't cancel, so the molecule is polar. The intermolecular forces that are present would be dispersion forces. All molecules have dispersion forces. And because it's polar, dipole-dipole forces. The hybridization, again, is determined by the electron geometry. It's octahedral, so it's sp3d2. 5 single bonds means there's 5 sigma bonds, and no double bonds, no triple bonds, means there can't be any pi bonds. Okay, that's IF5.